Okay, it's been a week. So hopefully we're able to get something out of the reading you did today from the textbook and make connections back to the work we've done on electronegativity and maybe even connections to the new information that I gave you on that test. Um, so here's the thing. We're going to move on to more than just talking about atoms and particles and start building things, building compounds. What do these atoms and particles do when they stick together? And as you should have noticed from the reading today, the first set of compounds that we care about are binary ionic compounds. Thinking about how we break down words and break down phrases, it should make sense that binary means two. Ionic means it's a type of bond where the electrons are taken or transferred from one atom to the other, and you have a thing that is now made up of individual ions. The connections that you need to make to old material are recognizing that the electronegativity was weakest in the area of the periodic table that contained metals, and the electronegativity was strongest in the area of the periodic table where we had nonmetals. That's the left hand side of the periodic table is low electronegativity, and the right hand side is high electronegativity. Just like mostly to the left we have metals, mostly to the right we have nonmetals. And recognizing the dividing line is not really in the middle, it's in that diagonal staircase area on the right hand side. So, piecing everything together, going way back to the beginning of the year, talking about particles and particle collisions and changes that happen there, I want you to think about two atoms colliding, one metal, one nonmetal. When those two atoms collide, there ends up being a tug of war over an electron. The nonmetal will always win that tug of war. The nonmetal is our polar bear. The nonmetal will take that electron from the metal, and that nonmetal will now become a negative ion. It has gained an electron, it is now negative. The metal has lost an electron, it is now positive. Overall, everything is still neutral. There is one positive, one negative. Those two things are now very close together, oppositely charged. They will attract to one another and stick to one another. This is how you form an ionic compound. You take two neutral atoms, you mash them together, you transfer an electron, and now the opposite charges cause them to stick together. The key here is everything overall remains neutral, but the individual pieces are positive and negative and hold themselves together. That is what you need to be able to get out of the reading that we did today and the connections to old material. Our goal for the rest of the semester is to take these ideas and expand them. We're going to bring in the covalent compounds as well, but the idea of you can take everything we learned last semester, put it together for a mechanism, and use that to understand the new material. If you can do that, everything will be good. Hopefully, I'll be back soon, and you can ask me questions, and we can work together to kind of forward our knowledge in person.